This is topic 3.4, differentiating inverse trig functions, okay? These are all inverse trig functions. So the inverse of a trigonometric function x may be indicated using the inverse function notation F inverse or, and I know you've seen this before, arc, okay? So sine inverse equals arc sine. So it's really important to rewrite that as sine inverse when you see it. We're going to jump right into these formulas. I'll talk about them once we get them written down. Let's talk about the sine inverse. It's 1 over the square root of 1 minus x squared. Okay? Now, cosine, and by the way, for cosine means the complement, okay, of the sine. That's where that co comes from. So the complement of the sine, cosine, is the opposite of 1 over the square root of 1 minus x squared. So they look identical, except for the co is a negative, and we expect that. The other very important one is the derivative of the tan inverse, and it's 1 over 1 plus x squared. And if you say that a few times, you'll remember it. 1 over 1 plus x squared. And I'm going to tell you right now, this tan inverse is seen all of the time, and we use it when we integrate. You have to know that the derivative of the tan inverse of x is 1 over 1 plus x squared. I'm going to give that 2 stars. I'm going to give these 1 star each. You need to know all 3 of those. The other ones, we'll just call it formula calculus for this at this time. You'll just probably be given the derivative, and you'll just have to know how to use it. So it looks like this. This has an absolute value of x on the outside, x squared minus 1 under the root. The cosecant looks just like that, but it has a negative in front of it. Absolute value of x, square root of x squared minus 1. Now, cotan inverse is just the opposite of 1 over 1 plus x squared. So I think you can do pretty well with those. We're going to jump right into the derivative. We want the derivative of the sine inverse of 3x. So if we're looking at the derivative of the sine inverse of 3x, what we're going to need to see is that our 3x is their x, okay? Which will be this x. So it's really important. So that is equal to 1 over the square root of 1 minus 3x all squared. Since we didn't just have an x, we have to use the chain rule and multiply by the derivative of the something. You could say that's the derivative of the something. I wrote that so big really quickly, I'm going to write it a little bit smaller. So I can have room to simplify. 1 over the square root of 1 minus all of 3x squared times 3. And that's equal to 3 over the square root of 1 minus 9x squared. And we're actually leaving it like that. Keep in mind the square root of 1 minus 9x squared is not equal to the square root of 1 minus the square root of 9x squared. That is very wrong, okay? So this is our answer, 3 over 1 minus 9x squared under the root. Let's move on to the tan in, okay? The tan inverse derivative is always 1 over 1 plus x squared, and our x is a 2x squared, and we need to square that, multiplied by the derivative of the something, which is 4x. Our something is 2x squared. So now we end up with 4x over 1 plus 4x to the 4th. Arcsecant, remember, this is equal to the derivative of the secant inverse of 5x, okay? Now, we're going to go to our formula up there. You do not have to memorize this. It is 1 over the absolute value of 5x times the square root of 5x all squared minus 1, okay? So now we're going to have 1 over, and we have to multiply by the derivative of the something. Now, you need to convince yourself that this 5 can come out of the absolute value. Absolute value of 5 is 5, so come out and cancel that. And so now we have 1 over the absolute value of x times 25x squared minus 1. Okay, let's go ahead and look at some simplification answers. We're just simplifying these. And so sometimes it's nice to talk about the algebra. One thing I want you to notice here is that the secant inverse function, if you look up here, the secant inverse function is positive, okay? So if x is equal to, let's say, even a negative number, what if x is equal to a negative 1? This would be positive. X equal to negative 1 put under the absolute value. When it comes out, it's a positive 1. So this is always going to be positive. You could think of it as a positive over a positive. So it's positive. Okay? So we just want to talk about that. And so we can actually cancel this x squared and just leave an x in that denominator. And then, of course, our 9 can become a 3, and this 3 can be canceled. I really don't like writing on my work like that. But anyway, you can see that this is simplified as 3 over the absolute value of x times the square root of 9x to the 6th minus 1. Let's look at another one. You can see here that what if x is equal to a negative 1. So we have to be careful because that numerator would be negative over a positive. So we are going to have a negative. So we can't just be, frivolous. We do have to make sure we know what we're doing, okay? So the absolute value of 2, of course the 2 comes out as a 2, and that would reduce this 4 and leave a 2. Now, the x over the x squared, since this x is already negative, it will take one of these x's away. So we're just left with a 2 in the numerator. And this x can come out of the absolute value because it's going to be negative anyway. And then we have the square root of 4x squared minus 1. So whatever x is, if it's negative or positive, that's what will remain since there was this x in the numerator already, and it would take that sign. Okay, let's talk real quick when we're asked to find the inverse of a function, and you memorize these intervals in pre-cal. Keep in mind when you answer a question about the sine inverse or what these y values are, the sine inverse only takes on these values, okay, from negative pi over 2 to positive pi over 2, okay? Of course, the domain is negative 1 to 1, but the range will only be those values. Let's talk about the cosine inverse function. The y values, what you would give your answer for, would only be between between 0 and pi, okay? Starting here and going all the way to pi. And finally, the tan inverse will be here from negative pi over 2 to pi over 2. This has something to do with the one-to-one functions. And you memorize these because inverse functions are one-to-one functions. Inverse functions are inverses of one-to-one functions, okay? And in order to be one-to-one, you have to have a unique y value. Okay, let's work these 3 problems. I just want to make sure you know that we will have unique answers when we come up with these. So the first thing we're going to look at is on f of x equals the sine inverse of x. And here, if x is root 3 over 2, we want the sine inverse of root 3 over 2. So what they're asking for is that angle whose y value is square root of 3 over 2, and that is pi over 3. Why is that? Because the sine of pi over 3 is equal to root 3 over 2. I'll put since. Okay? Let's look at the next one. F of x equals the cosine inverse of x over 4. What we will have is at x equal to negative 2. We're looking for the cosine inverse of negative 2 over 4, which is the cosine inverse of negative 1/2. So we're looking for that angle who has a y value, a cosine value of negative 1/2, and that is 2 pi over 3, since, let's write that down, since the cosine of 2 pi over 3 is negative 1/2. Okay? Let's look at our last one. Our tan is the tan inverse of x, and what we're looking for here is the 1 over root 3. So the tan of theta is equal to 1 over root 3. So what would that angle be?